Bismillahirrahmanirrahim. Assalam O Alikum. Dear student, today we will start new syllabus KPK Book Foundation Physics SSC 1 Unit number 2. In Unit number 2, Kinematics. What is meant by kinematics? The motion of an object without any cause, that is called kinematics. Now we will discuss SLO base according to FBISC requirement numerical problems question number 1 to 6 in part 1. Now start our lesson numerical problem question number 1. In question number 1 given statement according to this diagram, east, west, north and south. Here body is moving along east and west in this direction. Here arrow sign are given. Now we will consider as a required velocity of 15 meter per second west to 25 meter per second in east in 0.10 second. Now we will determine the vector acceleration of crash ball. Now first of all write the given data. Initial velocity in the direction of west, that is equal to Vi is equal to minus 15 meter per second, because here this point is origin. Along this direction value is positive and toward the left side value is negative. Similarly, toward the upward value is positive and toward the downward value will be negative. So initial velocity in the direction of west will be negative. So Vi is equal to minus 15 meter per second, and negative sign is used with the velocity initial velocity Vi because it is opposite to Vf. Similarly, we use the final velocity in the direction of east. Vf is equal to 25 meter per second. Given time t is equal to 0.10 second. Now we can find that acceleration A is equal to question mark. First of all, using the formula to find the acceleration. So as we know that according to the first equation of motion, Vf is equal to Vi plus At. Here we can find the acceleration, then A is equal to Vf minus Vi divided by T. According to the definition of acceleration, what is meant by acceleration? The rate of change of velocity, that is called acceleration. So rate of change is equal to Vf minus Vi divided by T. Then acceleration A is equal to Vf minus Vi divided by T. Putting the values, then A is equal to 25 minus into minus 15. Here minus multiplied by minus will be positive. Divided by 0.10. So 25 plus 15 divided by 0.10. Here the final answer of acceleration is equal to 400 meter per second. Now we will move in the direction of opposite velocities Vi and Vf. Then, so the acceleration produced by the ball is 400 meter per second in the direction of east. Now we can solve numerical problem question number 2. In question number 2, a golf ball with initial traveling at the 25 meter per second hit a sand, then slow down and the acceleration is minus 20 meter per second square. Find the displacement after the time 2 seconds. Now, first of all, write the given data. According to the given statement, initial velocity Vi is equal to 25 meter per second and acceleration A is equal to minus 20 meter per second square. That is called a deceleration. Time T is equal to 2 seconds. Now we can find that displacement that is denoted by S. Now we using the second equation of motion. In second equation of motion, S is equal to VIT plus 1 upon 2 AT square. Then putting the values, we have S is equal to 25 multiplied by 2 plus 1 upon 2 into minus 20 multiplied by 2 square. Then solve this value. 25 multiplied by 2 is equal to 50 and 2 square is 4. Then S is equal to 50 plus 1 upon 2 multiplied by minus 20 multiplied by 4. So S is equal to 50 plus 1 upon 2 multiplied by minus 80. 80 divided by 2, that will be equal to minus 40. So S is equal to 50 plus minus 40 is equal to S is equal to 50 minus 40. Then the displacement of a body S is equal to 10 meter. So the answer is 10 meter. Now numerical problem question number 3. In question number 3, a bolt accelerates. The length of the gun is 0.750 meter along with a magnitude of 5.3 multiplied by 10 raised to power 5 meter per second. With what the speed does bolt exist the gun? Now, first of all, write the given data. According to the given statement, write the given data. Initial velocity Vi is equal to 0 meter per second. Why we use 0 meter per second? Because at a rest. So, at a rest, velocity will be 0. Now, initial velocity Vi is equal to 0 meter per second. Distance covered S is equal to 0.750 meter. Now acceleration A is equal to 5.35 multiplied by 10 raised to power 5 meter per second square. Now find the final velocity. We have by using the third equation of motion 2as is equal to vf square minus vi square. Putting the values, then vf square is equal to 8.025 multiplied by 10 raised to power 5 plus 0. So taking square root on both sides, then vf square is equal to 0.8.025 multiplied by 10 raised to power 5 in the form of square root. Vf is equal to 8.080.25 multiplied by 10 raised to power 2 whole square root. Here square root cancel by square root and taking the square root of 80.25. So Vf is equal to 8.958 multiplied by 10 raised to power 2 meter per second. So final velocity is 8.96 multiplied by 10 raised to power 2 meter per second. Now the final velocity, we can write that 896 meter per second. So we will move the numerical problem question number 4. In question number 4, according to the given statement, our driver is traveling at 8 meter per second. When she see a red light ahead, here car is capable deceleration at the rate of 3.65 meter per second square. Now, if she applies the brake when she is only 20 meter from the instruction when she see the light, will she be able to stop in a time? So first of all, write the given data. Initial velocity Vi is equal to 18 meter per second and final velocity at a rest, so body will be stopped. Vf is equal to 0 meter per second. Now acceleration A in the form of deceleration because body will be stopped and applying the brake. Final velocity will be 0, so acceleration in the form of negative. A is equal to minus 3.65 meter per second square. Negative sign shows that deceleration because velocity of car will be decreased. Distance between the car and the red light S is equal to 20 meter. Now you can find the actual distance covered S2 and further distance covered S. Now first of all we calculate the actual distance covered S2 with the deceleration by using the equation of motion. In third equation of motion, 2as is equal to Vf square minus Vi square. Then S2 become 44.4 meter after putting the values. Now we will calculate S. Then we find the S. Here the distance covered by a car with the given deceleration is 44.4 meter, which is the greater than the remaining distance. So 20 meter between the car and red light, thus the driver will be able to stop the car within 20 meter. So we can finding the distance covered by S. Then we have S is equal to S2 minus S1. Putting the values, S is equal to 44.4 minus 20. Then S is equal to 24.4 meter. Now, so she will be goes 24.4 meter past the light. Now we can move the next numerical problem, question number 5. In question number 5, given statement constant acceleration is 2 meter per second. Cover cross a point where its velocity is 5 meter per second. After 6 seconds, how much distance is covered and what is the velocity? Here we can find distance covered and velocity. First of all, write the given data. According to the given statement, acceleration A is equal to 2 meter per second and initial velocity Vi is equal to 5 meter per second. Time taken T is equal to 6 seconds. Now we can find the distance covered S and the final velocity Vf. Then for finding the S, we use the second equation of motion. In second equation of motion, S is equal to Vit plus 1 upon 2 at square. Putting the values, then s is equal to 5 multiplied by 6. 5 is initial velocity multiplied by 6 is a second in a time, plus 1 upon 2 at square. Acceleration is 2 and t value is 6. So 6 square. Then S is equal to 6 5s are 30 plus 1 upon 2 multiply by 2 multiply by 36. 2 cancel out by 2, then distance S is equal to 30 plus 36. So the distance covered S is equal to 66 meter. Now we can find the final velocity using the first equation of motion. In first equation of motion, Vf is equal to Vi plus At. Now putting the Vf is equal to 5 plus 3 multiplied by 6. So 5 is initial velocity plus 3 is its acceleration, 2 is acceleration multiplied by 6 is time. So Vf is equal to 5 plus 12. Here value is 2. 6 2s are 12. We write 12. 12 plus 5 is equal to 17 meter per second. Now in a last numerical of today topic, question number 6. With what speed must be a ball thrown vertically in the form of this? Ground level to rise a maximum height 15 meter. Here 50 meter its height. So final velocity Vf is equal to 0 because body reached at a maximum height. S distance is 50 meter. Value of G is negative because body moving upward. G is equal to minus 9.8 meter per second square. And find the initial velocity. Now, given data, final velocity Vf is equal to 0 meter per second and height h is equal to 50 meter. Now, acceleration due to gravity g is equal to minus 9.8 meter per second square. Upward motion g is negative. So, value of g is minus 9.8 meter per second square. Then find initial velocity Vi is equal to 0. In a solution, by using the third equation of motion, 2as is equal to Vf square minus Vi square. Putting the values, 2 into minus 9.8 is the value of gravity. Here acceleration is equal to gravity of gravitational acceleration. Multiply by s is a 50 is equal to 0 minus Vi square. Vf is 0, so Vi square is equal to 980. So taking the square root on both sides, then we find the initial velocity. Vi square is equal to 980. Taking square root on both sides, then initial velocity is equal to 31.3 meter per second. Best of luck. Subscribe our channel. Take care.